I will shut up, and Sabine, you can take it away.
Sure. Moment. I have to share my screen first.
Yep.
And I hope it is now the correct version. A moment, let me look. Yeah. So, thank you to Kelly for this nice introduction. I'm really happy and feel honored that you invite me for this conference. My name is Sabine Heinz. I work as an artist in Berlin, and for my work, I use different techniques such as oil or acrylic painting, collage techniques, and mixed media. In my pictures, I try to combine scientific content with artistry, but also to use scientific processes in an artistically effective manner. I've included now in my presentation some answers from the Q&A part because I got some emails in advance. So my presentation is slightly a bit longer than it was supposed. The starting point of for one of my series was a lithograph. I manipulated in various ways by painting over it. You can see the litho stone and how it works. Alois Senefelder was an inventor of lithography, and actually he was a theaterman, and he was looking for a way how to produce produce many of his programs in an easy way. And after much experimenting, he became familiar with the interaction of fat and water and developed planographic printing from that phenomenon. As I told you, lithographs are etched on stone slabs, and on the left-hand side, you can see the lithograph stone, and it's the original where I painted over, from this print, then I painted over. So here you have two examples, and I left always something from the lithograph, something from the lithograph remained in my picture, so you can see what was behind this, yeah. And lately I've been focused more and more on the inclusion of fluorescent and phosphorescent colors. This gives me the opportunity to hide things in pictures that only became visible when the pictures are stimulated with UV light. There are two pictures in one, so to speak. And but you can, here, and I was talking in my lecture about fluorescence and phosphorescent paints, and here you can see the effect. On the left hand side you see the original picture, in the middle you see the picture hidden with UV light, and on the right hand side you can see the picture with phosphorescent paint, the phosphorescent paint part on the picture, the moon appears when the UV light is switched off. Moment, why it does not go ahead? Yeah, but you can also make things visible through other representations, such as these trees. It is an artistic or artist impression, but you can see that the tree does not end on the surface of the earth, but that its roots reach deep into the earth. You can see the sediment layers and that they are of different composition and color. In times when our big city children think that cows are purple because they are printed that way on milk chocolate, this cannot be taken for granted. They are painted in purple color, yeah. And people in the big city in particular sometimes have little connection with nature. In my lecture, I was speaking about the difference between fluorescent and phosphorescent color. I mentioned this with, and I also mentioned bioluminescence and chemiluminescence. In the rooms of my exhibition, we also presented a banana plant. Yellow leaves of banana plants glow blue when hit with UV light. This luminescence is generated by breakdown products of the green leaf pigment, chlorophyll, which are equipped in a very unique way with special sugar molecules, so they are hypermodified, and which accumulate in the aging leaves. Fluorescent degradation products have been detected earlier in aging leaves, but so far only as short-lived intermediate products. The special thing about the compounds from banana peel and leaves is that they are long-lived, also persistent. Persistent, ja, Punkt. Moment, irgendwie geht das hier nicht weiter. I cannot, yeah. Thank you to Linda Billings for her email. Of course, I also looked for fluorescence in the animal world. It's really fascinating what glows under UV light at night. As mentioned in my talk, fluorescence seems to be particularly widespread in the sea. Many jellyfish, corals, crustaceans glow under certain conditions. This glow is also common among fish, as biologists discovered only a few years ago. There's a simple reason why this has remained a secret for so long. The glow is often invisible for our eyes. We would need a filter to make the bright colors visible. But many animals have exactly this filter and can perceive their fellows. One example of this is the so-called green fluorescent protein GFP from the Acorea jellyfish, which is now playing an important role in medical research for marking cells. The result you will see later on some other pictures when the works are excited with UV light, they glow in the dark. GFP is a protein molecule and is built like a barrel with the dye molecule enclosed within. It's in a cage and therefore cannot move. Irradiated light is re-emitted as fluorescence. And here you have some bacteria and también, and also some viruses. Here are bacteria, and you can see on the left-hand side the original, without UV light, and on the right-hand side you see it simulated with UV light, and it gives also like 3D effect, yeah, when watching it, and yeah. And in the medicine or in the research, they are working with this marking cells. Here you have a coronavirus, and this gives also a nice, yeah, or another perspective to the people to see it under UV light, and that has some aesthetics, yeah. So there are also luminous representatives among the species living on land. Researchers are finding more and more land dwellers with glowing effects, including arachnids such as scorpions, reptiles such as chameleons, amphibians such as frogs and birds. Mammals, on the other hand, are extremely, Moment, ich muss mal hier zurückgehen. How can I go back? Okay, I leave it like this. Extremely rare among these finds. Until recently, only a few marsupials were known to be capable of biofluorescence. It is therefore all the more amazing what the team of biologists led by Alison Kohler from Texas A&M University in College Station made public in 2019, the discovery of fluorescent flying squirrels. Rather by chance, the scientists found out that fewer of the new world flying squirrels native to America glows in bright pink tones under UV radiation. The question arises as to why. It is believed that the glow serves as a means of communication and possibly as a courtship decoration to signal readiness for mating. Researchers from Uruguay have added fluorescent jellyfish DNA to the genome of sheep. The result seems bizarre. The animals store the light and glow in the dark. Researchers, only to mention it, from South Korea had already created a clone dog in July 2011 that can be made of to glow in the dark using a kind of switch. Thanks to a fluorescent gene, the dog glowed in the dark as soon as antibiotic doxycycline was added to the animal feed. This enabled scientists to switch the dog's luminosity on and off. By cloning genetically modified animals, researchers hope to make advances in the treatment of genetic defects in humans. The same they are doing in marking cells, they switch it on and they switch it off, the fluorescence. Hydrogen peroxide is a pale blue, also colorless and diluted form, largely stable liquid compound made of hydrogen and oxygen. It is very strong oxidizing agent and as such reacts violently with substances such as copper, brass, and potassium iodide. I have made use of the oxidation process in my work with iron and copper primer. I painted different portraits and then subjected them to the oxidation process by painting over them with various catalysts. The idea behind this was that just as with the aging process in humans, you don't know exactly what the result will be. You can exert only limited influence on the process. For the pictures, I worked together, for these pictures, I worked together with a SSoCIA company, which is using algae to improve air quality. We combined parts of the algae carpets with my oxidation technique and tried to find out to what extent oxygen produced by the algae acts as a catalyst for the various primers. Unfortunately, the results were not satisfactory and that we couldn't determine any significant influence on the oxidation process. Furthermore, we had to interrupt this work because of the coronavirus pandemic. However, further experiments are planned under laboratory conditions where, among other things, the oxygen content can be measured. Also we have then tight containers and so on. So we are curious, naturally curious to see where this effort will take us. Science and art are two different ways to approaching reality. Sometimes work of art say more about reality than science can because aesthetics and emotions play a major role. As an artist, I can depict things differently and make them visible. I'm not bound by the exactness of science. I can exaggerate things and therefore make them easier to understand. For example, in this picture showing the surface of the moon. But if I stimulate the picture with UV light in the dark, these tardigrades appear, which are extremophiles able to live in extremely harsh environments. In April 2019, the Israeli space probe Beresheet crashed on the surface of the moon. This ill-fated probe had thousands of tardigrades, each less than a millimeter in size on board. You can see both pictures to compare it. In this picture, you first see a cosmonaut and the ISS over the Earth. But when I stimulate the image with UV light, one can clearly see the light pollution on Earth. This then comes to the foreground and changes the message of the picture. So it can be said that even our planet glows in the dark. But this is not an effect of fluorescence. So if aliens are looking for us, they just have to follow the light. In this picture is given an imaginative look at what it might look like beneath the icy skin of a watery moon. It was also a challenge by Art Imaginarium hosted by City Institute. And if there is life on such words, it exists in simpler form. I have pictured here on the left-hand side bacteria, admittedly oversized again, but they would also have to be extremophiles who would need to endure a core word that is perpetually dark. In my pictures, I tried, so on the right-hand side, you see two rivers which encounter. In my pictures, I try to build a bridge between art and science, not only thematically, but also in terms of color technology and color experiments. In this picture, you can see the Milky Way, and on the right-hand side, it's animated, digitally animated, it's spinning around. In earlier times, the church used art to bring its content to the people who for the most part could not read and write. Today, science can use art to bring its content to a wider public and to encounter the people with crude, strange theories. Science does a lot to all of us, and it's our past and also our future. And in this context, I would like shortly to mention Robert Koch. His research in particular has an impact up to the present day. He did research in the field of bacteriology and was able to bring about the introduction of hygiene standards in medicine, and thus, among other things, drastically reduced infant mortality. It is also important that hygiene measures are taken with coronavirus. Even if viruses and bacteria are different, you can successfully protect yourself against them with these preventive methods, and it's the side of science. At all times, scientists have also been influenced by artists. Take science fiction literature, for example. This is where the term terraforming comes from. Many astronomers and researchers have been inspired by science fiction literature. But as we learned yesterday in the film about Chesley Bonestell, he artistically presented scientific content in an excellent way, and thus conveyed first impressions of the nature of the surface of planets or the appearance of rockets and other flying objects. And I'm trying to do the same in this picture. This is the Milky Way when the Milky Way is being settled. You see in the foreground some technical structures like Dyson spheres, and they are connected. The sediments are connected between each other. And in my pictures, I try to build a bridge between art and science, and not only thematically, but also in terms of color technology and color experiments. So I thank you for your patience. And yeah, so I have to close my, so I'm back.
Okay, so that ran a little bit long, but that's okay. It looks like Flora Dutra is probably not going to be presenting this afternoon, so I'm not as freaked out about running over this time. Let's take 5 or 6 minutes or so to talk about that. So who wants to go first? Robert, is that our hand, or you just, okay, so Robert, go ahead.
Sabine, have you ever heard of tetrachromats?
What?
So, you know, human beings have 3 kinds of color cones in their eyes, but there's apparently a mutation. The highest, it's sex-linked, and the highest occurrence is in the Mideast, maybe 1% of the population. It's sex-linked. It occurs only in females. They have 4 cones.
Mm-hmm.
So there's a color that tetrachromats see that most.
That they cannot see green and red, yes.
Well, there's color blindness where they can't see, but then tetrachromats can see one other color that most other people can't. And I would recommend to you to find out if there are any tetrachromats whom you know, and expose them to your art. And,
but what
go in an interesting direction.
Yeah, but what is in this regard interesting, in my exhibition, a woman approached to me and she said, it's interesting to see things with under another light. So like to say, to see things from another point of view. And this is nice. And this is what I wanted to say, also to say that people, they could experiment with the lamps and see the plant and the pictures, how they change, but also that they could have another point of view and to interest people in science, that they see the bacteria and viruses and they see it with a nice eye. You know what I mean? Also, they don't see it so with fear, they were impressed. So, and that makes them curious. And this can be a bridge between art and science. And I'm really grateful what Kelly said at the beginning, that we need this bridge, between art and science.
Yeah, I'll just make a quick comment along those same lines. If you're ever looking for a really good example of sort of cultural sensitivity of what seem to be objective concepts, color is a great one, because not every culture divides up colors the same way. And whenever I point that out to my students, they're always blown away because they think of color as just an objective given. And then you're like, well, some colors don't, some cultures don't have a word for blue. So, anybody else? Okay, Sarah?
Yeah, I thought one thing that's kind of interesting, right, in the issue of looking at it in other kinds of light. I know in the history of astronomy community, one of the discussions has been about astronomical images, and some people that work in museums have told me that they have this problem when they show images. People get very upset if they think the image is not real. And when they start to realize that the images are a compilation that, takes other kinds of light and interprets it in a certain way to construct an image that we can see. And I wondered, do you have any sense of, does any of that kind of come up in people's experiences with looking at your images in the different types of light? It seems like because it's art, because it's constructed and you're there as the artist, it is real, despite the fact that they can recognize that it's not a type of light that we would normally see. But I wonder, I don't know, I'm just wondering how you would reflect upon that sort of reality of an image in types of light that we're not able to perceive.
Yeah, but that is an interesting thing. I figure so that when people take the UV light and they can experiment with a normal picture, also without UV light, and hit them with UV light. And I explained them in the exhibition the difference between fluorescence and phosphorescence. As I mentioned in my lecture, that the dials of the clocks were marked with phosphorescent colors. Or here in Berlin, you have many old buildings where in the cellar are marks with phosphorescent colors from the Second World War. Yeah, so but I think it is another approach that when people can experiment by themselves with lamps and see, oh, it appears and it has a 3D effect suddenly, and it looks amazing, and yeah.
Okay, William.
Yes, Sabine, I'd like to ask a question that I think I'd love to hear your insight and your experience in a way that will inform Kelly's earlier question about the inclusion of how to include art into SSoCIA. And my question has to do with your own experiences in terms of your training and your inspiration, but even more to the point, Any barriers that you've encountered in terms of critique and curation? This whole notion of gatekeeping within the art community, which of course has its own social customs that are different than many of the academic customs and organizations that we're used to.
You are right. Yeah, I had a nice conversation with my boss last week because I showed this presentation to my colleagues, and he told me, also I work at Humboldt University Institute of Chemistry, and he told me, yeah, but it's nothing new and so on. And I said, yeah, but it's another approach, and I can make it public, yeah, so, and easier to understand for people who have no connection with science. And this is the point, I think. And when I started with this fluorescent colors, the idea came because I was working on an artist book about astronomy. And I had some paint, some pencils, and I was hiding, for example, from the law from Kepler, and I wanted to have the pictures, and then if you put UV light, and then you have the scientific explanation, yeah. So, and this was the idea behind this, and then I bought the colors, and I started to experiment with the glow-in-the-dark colors, with the fluorescent colors. And yeah, but it depends. Also, it depends from the scientist point of view. Also, if the scientist came to an artist, he cannot expect that I have the science in my head. Yeah. Also, now I read a lot of about what is fluorescent in nature and so on, because I was interested in this. Yeah. But you cannot expect this, and then you have to explain it to the artist. Like to a child, you have to make it understandable, and then I can transfer it in a picture to depict this to other people. What do you mean? Yeah. So, and I think it's an interesting process, because the scientist has to think it over and to think how to explain it in a simpler way, and I can transform it to show it, yeah. And as I told in former times, the church used the same medium because people were not able to read and to write, so they depicted the history of the Bible in pictures, yeah. So, and nothing else we are doing now, or we are trying to do with our pictures, and transforming science in art.
Okay, so thank you very much.